Welcome to Ozone Engineering YouTube channel. Here we like to talk about different engineering problems and modeling techniques to solve these problems. Today I'd like to talk about a particular Ansys tool. It's called Icepak, and it's a specialized software that predicts the thermal field and cooling solutions for IC packages, printed circuit boards, and all the way up to complete electronic systems. Icepak also comes with numerous macros, and one of them is pretty interesting that I'd like to concentrate on in this video. It is a macro that automatically builds and executes a JEDEC test environment. And so within this test bed, what we do is we place an IC thermal package, and then we're gonna calculate the thermal resistance from the IC package to the case, which is called theta JC, and IC to board, which is called J to theta JB. So for this purpose, I have opened up our latest version of Ansys Icepak 2024 R1, and the first thing I do is I click on library, and then here what you can see is Icepak comes with a wide library of pre-existing components like fans, filters, heat sinks, and we're going to look at packages. So I'm going to expand on packages. As you can see, that there are possibly dozens of different IC packages that were built for us. I'm going to pick one of the larger packages. You can try this on any one of them, and when I double clicked on it, it essentially placed it in our canvas. What I'm gonna do is I'm gonna go auto scale our cabinet so it essentially wraps around our geometry. I'm gonna go to orient and click home position, which is going to zoom in automatically, and now we can see our IC package and the environment around it. So in order to prepare for this macro to run, all I need to do is do a couple of things. One of the first things is I do need this surface area that you see in gray here, and that's in the Z and X direction. So if I were to look at the same geometry, if I look at X start and X end, what I see is, from start to end, this 4 centimeter by 4 centimeter square. So let's keep that in mind. We're going to use this as the area value in the script. So what I do is I do right click on our component, then I'm just going to do edit, or I can double click and it's going to bring up some basic information about this readily available component. So I'm going to increase the priority to 20 just to make sure our component gets the highest priority during the meshing stage. And essentially, we have these basic dimensions which we talked about, this 4 centimeter by 4 centimeter chip. If you click on schematic, it's going to show the basics of the package. And if we click on component visibility, we can turn, for example, substrate on and off. Or one thing we care about is the die. So here I'm turning it on and off. See, it's that top gray level we see. So it is facing the maximum Y direction. That's also another note that we should take. So if we go to our die, and let's just put 10 watts of power, which is going to be dissipated from this component. I hit update and then hit done and close this window. So next step is we go to macros. It's a modeling macro under IC packages, and it's called extract JB and JC. So once I click that, this is going to bring up this new window. And what I really want to do is I want to do thermal characterization for JC and JB, both of them, so I'll pick both. The package top side, as we decided, was max Y because the die is at the max Y location. Ambient temperature of 20 degrees C. We're going to use array package type, and we already looked at the top surface area. It's 4 centimeters by 4 centimeters, which is about this much in meters square. We're going to use the default high heat transfer coefficient on top wall, and for these are for theta JC. For theta JB, I'm going to leave the options as default, and actually, you know, we have two choices. It can either place this chip on a JEDEC 2S2P standard board, or we can pick a simple FR board. But you know, let's go with the default, and I'm just gonna hit accept, and then essentially the model's gonna automatically start setting up, and it will start running. So I hit accept, and as you can see the progress here, it's meshing. It's going to do the JC calculation first. Once that's done, it's going to do the JB calculation. And this operation will take less than 5 minutes. So as promised, after about a little less than 5 minutes, we have our theta JC and theta JB solution. These two windows you see are typical with Icepak. As you know, it runs a Fluent solver in the background, and it shows the convergence history. And on the left side, we have this smaller window which tells us the theta JC and theta JB values in degrees centigrade per watt. Please keep in mind that at Ozan Engineering, we're ready to help with your engineering simulation problems regarding Ansys software, and you can always contact us at ozeninc.com. That is OZENINC.com. Thank you.